Now, in this session, we'll be exploring and we'll be doing a small mini project inside SolidWorks. And in this complete process, if you have any questions, doubt, you can ask. So, without wasting much time, let's dive into the SolidWorks. So, here you can see right now we are inside the SolidWorks, and today we are going to make a simple part, a simple thing that is very useful, and we'll learn how we can do that and what are all the process involved, right? And we'll be doing a very simple project, like an enclosure for something, and then we'll see how the process actually works and how we can create something that is useful and also practical kind of design into your process. So we'll start with again with the same concept. Uh, with the same concept, we'll go onto the file menu and we'll start with this part file. We'll click on this new and we'll start with the part file. And in this, I'm not going to follow the normal approach. We'll be taking some advanced step to create something that we can. So basically we can call it advanced modeling inside SolidWorks. So that is what we're going to learn today, and we'll show you what does exactly when we say advanced modeling means, right? So we'll go on to the features tab, and you can see there are so many tools over here, and also the same inside the sketch panel and then inside the surfaces, right? But here inside sketches tool panel, there is a one special tool. There is very one special tool that you can see over here, and that tool is known as sketches. So before we'll start these sketches, if you have any questions, if you have any doubts, or if you have any specific learning that you want to learn about, just let me know into the chat box. It is, do you have any specific things that you want to have in the today's session? Because today's session is all about practice session. So if you have any doubts, queries, or questions, you can ask, and I will guide you how we can do that step-by-step process. I hope you are the only person who have asked me to do some advanced design in last session, right? So see, inside SolidWorks, there is one special tool that we have not explored because that is not required at this stage for you, and we are going to see. Okay, so you wanted to have a session on constraints. Okay, no problem. So see, since I already explained most of the tools inside SolidWorks, still, since you are asking, I will just spend few more 20 minutes and will explain you in details. So what exactly constraint means? So whenever we talk about constraints, like it's only related to sketches, right? Constraints, it's all about sketches. You will be able to use all the constraint tools inside sketch panel only. And in SolidWorks, we do not call it constraint. The technical word inside SolidWorks word for the same thing is relations. So basically applying a relation between two entities, right? For example, once we'll activate the sketch, let's activate a simple sketch, select any plane because this is just a demo. So you can see we just activated the simple sketch, empty sketch right now, right? Now, since the sketch panel is active, now we can create any entities. Like if you want to define any relation with someone, how you can do that? At least for that, you need two person, right? Then only you will be able to say that he is the father or he is the son. If in a family there is only one person, then the relation does not make sense. But if in family, if the minimum two person is there, then we can apply some relation, or we can say there is a relation between them, right? In similar manner, inside SolidWorks, the same thing happens. Like if you want to apply or if you want to define some relation used, then it's any of your sketch should have at least two entities, right? It could be anything, right? It could be line, it could be circle, it could be rectangle, it could be arc, it could be ellipse, slot, polygons, arc, text, point, it could be anything. So all the things that you can see over here, all the tools, if at we can apply relation between any two of them, right? So let's start with the line first. So let's say we have a line, and since we have to start first line always from origin, but let's say I started from away from the origin like this, right? And I also created one more line like this, right? But during our sketching process, we felt that we have to make this line from the origin. We did it something wrong. So either you select the line and delete it and start a new line, right? Or else what you can do, you can drag this line and try to place it onto the origin, but that is not possible to do exactly. You can see that, right? So how to make sure that this point is exactly sitting onto the origin? And that's where the relation comes. So basically all these green things that you can see, these are the symbols of relation. So right now for this line, a relation is applied, and that relation is, if you'll hover over to the green icon, it will give you the relation name, and that relation right now applied for that line is horizontal line. This means you can extend the length of the line, but you cannot rotate this line at any angle. Why? Because horizontal constraint, horizontal relation is applied onto this line at this moment. That's why. Now let's say I want to bring this point and this point at the same point, right? So what I will do, I will simply press shift on my keyboard and will select both the points. And the moment you had selected two entities, that is both of them are points, and you can see on the left side on the properties panel just got opened, and here 2 points are selected, right? And once 2 points are selected, at the bottom SolidWorks intelligently giving me a relation options over here. Like if you have selected 2 points, then you can apply these three kind of relation between these 2 points. And what kind of relation we want to apply at this moment? We want this point to be sitting at this point, and that relation is known as coincident, like making the points at the same point. That feature is known as coincident. So definitely this coincident relation, so I will select that, and here you can see between these 2 points I had applied the coincident relation, and that's why that point just moved and shifted to the origin point. And why this point shifted to the origin? Why not origin shifted to that point? Because here in this design space, origin is already a fixed point. So if something is fixed and if you'll apply some relation, then definitely the one that is free to move will move on to the other point, right? That's why. And if I'll click on finish, now if we'll select this point, you can see here again a new relation just got highlighted, that is coincident. So now these 2 points are applied with a relation that is known as coincident. Now if you try to drag it, you cannot drag it because relation is applied. But anytime if you want to again make it free, you have to select this green icon. I have selected the green icon. I will press delete, and again we can move that because I just deleted that relation. So all the time you have the option to delete any relation between any of the line or feature. For example, if you select this line, can you see we have horizontal relation applied, and because of that we cannot rotate it. We can only change the length of this line because the length is not defined yet. So if we'll select this line, if we'll delete this horizontal constraint, now you can see the moment I deleted that horizontal constraint, I can make this line at any angle, right? But I want this line to be, let's say, completely vertical. So I will select the line, then under the properties panel, I will apply a new relation that says vertical. And the moment I will apply vertical, you can see next relation just got added to this line is vertical. So that way you can keep defining the relation to your entities or objects. Okay, so your question is how come the origin changes with different models? There is origin will always be on the same thing. Like if you are starting a part with a single part, origin will always be there, right? So if you have assembly, there could be multiple origins, but in case of single part, or one origin will always be there, and that will be red in color, right? There you can see. And now we want this line to be perpendicular to this line. And how we can do that? So right now if you'll select this line, you can see the vertical relation is applied, and because of that we cannot make this line perpendicular to this line because this line is already vertical. And if you want to make it perpendicular with this point, then we have to make it horizontal first, right? So I will select this one and will delete that constraint. Now I can rotate this line like this. Now I will select the line, I will make it horizontal first, and then I will make sure that this point and this point get coincident. Also, the moment you will select this line and this point, we are getting three different kind of relation. Can you see that? Let's talk about the first relation, that is midpoint relation. And the moment we'll apply this midpoint relation, you can see that line, that point just got shifted to the midpoint of this line, right? So if this line will divide, this is the midpoint, and automatically that got shifted to the midpoint. And the moment we'll select this line, can you see here this midpoint relation is applied, right? So that way you can apply relation between two objects. Let's go back, press Ctrl Z. Now again select the point and line. The other relation we have over here is coincident. So if we'll apply the coincident, you can see line got just touching to this line, but still we can move this line, right? You can see it. So both of these points became coincident. So if we'll select that, okay. So if we'll select that, the coincident must be getting highlighted, but if it is not getting highlighted, don't worry. Anyway, so that way we can apply relation. For example, you don't want to apply any, let's say we have created something like this, and we don't want to, I just want this line to be sitting over here, but I don't want to define dimension. I just want this to be fixed over here into this space. For that, if we'll select the line, there is another relation that is known as fix. So if we'll apply a fixed relation with any object and we'll click on finish, now this line is fixed at this position, but still we can change the length. Its position is fixed, we cannot move it anywhere, but its length is not defined at, so we can change the length, right? And if we'll select the line, can you see it's fixed? This means the position of this line is fixed. We can delete this fixed one, and then we can move this line anywhere across the space. Now I want this line to be vertical, so I will delete this horizontal constraint first. We'll select the line, we'll make it vertical, and now I can drag it and match it with this point. So the constraint can also be applied in another way. Instead of selecting the points, let's say we have this line, and I want this line to be touching to this point, right? Then this endpoint to this endpoint, and this endpoint to this endpoint. So first I will make this line horizontal. So we'll select the line, we'll apply the horizontal constraint, right? And then I will simply drag this point and try to place it onto that point. And automatically, you can notice whenever I am reaching near to that point, it's automatically snapping onto the point. And it's giving me an option that I am applying that coincident constraint, right? So that is also possible. Like just check your line and you can drag the other line onto this point like that. And the moment everything is touching to each other coincident, you will get a closed shape. And that moment you will see that your sketch just got converted to a profile. So this is the inside gray area is known as profile, right? But still this distance this distance is not defined, so we can move it, right? And let's create a circle and see what other type of relations we are getting. So let's say we have created this circle. Now I want this circle to be touching to this line, exactly tangent, right? So that word is known as tangent when some arc is touching to any flat surface, right? Like a wheel traveling on a flat road. It's like a wheel is always tangent to the road, and there is one single point of contact only all the time. That's why the wheel is having the most efficiency possible to reduce friction, because it has only single point of contact. But in case of wheel, it's basically there is a width of the wheel. That's why in that case we used to have this line kind of contact, not point kind of contact. But if we have a sphere, then we'll have a point, we'll get only point kind of contact, right? So here you can see we just created something like this. Okay. So we just created something like this. So we'll select these two entities. The moment we select it, can you see the new relation that you can see over here is tangent? So we'll apply this tangent constraint. You can see that this just got moved and became tangent to this point, right? And if you'll zoom in, you will always see this line, this arc is always tangent to the line. Even if it is not very clear onto this, if whenever I am zooming, it could be the reason of the graphics of your system, but that is exactly tangent, right? And that you can verify. If you select the circle, you can see this tangent constraint applied between this line. So all the time you can move this circle anywhere, but even if you'll move it away from this line, if you'll extend this line, this is always tangent. right? So tangent means it always will be tangent to this line, even in the virtual length. Right here, line is not extended, but still it is tangent, right? So we'll move it over here. Now let's delete that constraint tangent that we have applied. Now we can move this circle inside, right? And let's tangent this circle from all the four sides. So we'll select the line, we'll select the other line, and we'll apply the tangent constraint. We'll do the same thing on all four sides to apply tangent, 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 right? And once something is tangent across a circle, any rectangle, if it tangent across a circle, this means that that rectangle is, all sides are equal, right? And now if we'll try to adjust the shape of the rectangle, automatically the circle shape is also getting adjusted, because right now it's tangent, right? That way. Now there is one thing. So to define this, we only have to define the circle diameter. There you can see. And the moment you will define the circle diameter only, everything just got defined, right? So that way you can do. Okay, so this I think the drawing, how to create drawing files in the session is already over. We already covered yesterday, and the recordings will be uploaded tomorrow morning. So that session was yesterday. This is the last session, that is today, where we are discussing all kind of confusions. If you want to learn something specific, those things we will be discussing today only. So you are a little bit late. I don't know whether you have joined the study session or not. So please check into the group. We already finished that session. So how, your question is how to know which relation to be applied in geometry. So that depends upon the shape that we want to achieve. For example, let's say this is something we created, right? But we don't need this one. We need this line to be vertical, and we also want this to be touching. So it depends upon the shape that you want to get. So if I will make it vertical, because I know what kind of shape I need, because SolidWorks will never know what kind of shape I need. So I made it vertical. I will also make this line vertical. I will also make this line vertical, right? I will move this point if it is getting it wrong. I will make this line horizontal. I will make this line vertical, and I will keep a shape like this. So if I started from a very random sketch, but just by applying constraint, I got a shape that I need. So you have to know like what kind of shape you need. So even if you have, for example, let's say I want to create a horizontal line, but accidentally I had created a line like this. So if you zoom out from far away, it looks like a horizontal line, like, right? So even if it is a very small angle, like 1 degree, let's say, it will not be possible to identify. You can see this looks like a horizontal line, but this is not a horizontal line. This is a line with a very small angle. So in that way, you can have the completely wrong geometry that you want to achieve. That's why using the constraint is important. Like whenever you have confusion, simply select the object, apply the necessary constraints, and then you will have a perfect horizontal line. There you can see perfect horizontal line. And that's why it's important. For example, let's say I have created something like this, and now here we have a need to create an arc between these corners like this. So how we can do that? Either we'll create a circle and then we'll adjust it like this carefully, and even if we'll adjust it very carefully, it will not be possible to get the exact shape. So from far away it looks like it is tangent, but if we'll zoom in, you can see it's not tangent. So the best way always is to apply the relation between these two objects, and select the objects, apply that tangent relation, and that's it. Now this side is tangent, and apply tangent on this side as well. Now this is also tangent. But you can see these lines are not at 90 degree to each other. You can see this line is not horizontal and this line is not vertical. And how we can know that? We'll select the line, there is no vertical icon is there, and if we'll select the line, there is no horizontal icon is there. But the moment we selected the line, can you see this perpendicular constraint over here? This means this line and this line is already at 90 degree to each other. So even if we'll make this line horizontal, the other will automatically get vertical, because already we have this 90 degree angle, right? So that way you can control the constraint and you can define or adjust your shape inside SolidWorks. Now let me know if you have any questions. Let me know if you have any questions. So inside SolidWorks, basically we have so many tools, so many features that we have to learn. But anyway, now until now we were only exploring the 2D sketch, right? How we can create a 2D sketch. So here you can see, using this single sketch, we are able to create only flat sketches. But there is a one hidden feature inside SolidWorks, and that hidden feature is, if you'll go on to this icon over here and click on the search command, and that command is 3D sketch. So if you look for 3D sketch, just search for 3D, and you will be able to see that. Okay, so that tool we can find once we'll finish this sketch. So finish the sketch. So sketch one was completely 2D sketch that was created on a single plane, right? Whether it was front plane, top plane, bottom plane, whatever it is, but it should be created only on single plane. But let's search for this advanced command that is known as 3D sketch. So here, if we'll search for 3D sketch, here you can see the first tool that we're getting is 3D sketch. We'll keep this tool into our feature tool panel, right? Sorry, in sketch tool panel. So what is the benefit of having 3D sketch? So we'll show you now. First, I will delete this sketch one. Let's select it and delete it, or else we can hide it. Let's hide it, right? So we had made hidden data sketch. Now activate this 3D sketch tool. Same sketch process. Select the tool first, right? Activate the tool, and then the moment you will activate this tool, you do not have to select the plane. Just activate the tool and your sketching tool will be active. Now the benefit of it is, let's create a rectangle first from this point to this point like this. So you can see we have created a rectangle, but here also inside the sketch panel we can rotate this rectangle, and we can even add 3D features to it. Let's add another rectangle, not onto that plane, onto some other plane. So what we can do, we can activate the line tool and we'll create a line like this. There you can see. Okay. We'll try to create a vertical line, and 3D sketch is little bit complex to handle, because here you can see we created our first 2D sketch, and let's add some 3D feature to it, and that's what we are trying right now. So we are trying to create a 3D sketch, but it is still getting created in 2D. You can see it's onto the same flat plane. We don't want that. We want a line along this vertical axis, right? So we activated this 3D sketch. We'll activated the line tool. We'll select the points and we'll try to create a line, right? So let's create a line first like this. So you can see the line is along the same flat plane. So select the line, select the point. Okay, select the line, and I want this line to be along y-axis. So from where you can identify the axes. So here you can see at the bottom corner, you can see the z-axis, x-axis is red, and y-axis is green. So I want this line to be pointing towards z-axis. So I will select the line, and then under the relation, I will apply this option that says along z. And the moment I applied along z, you can see it just got created along z. But I don't want it towards bottom. I want it towards upward, so I can move it like this, right? Very simple. Now we'll do the same again on this side. I will do the same on all the 4 corners first, and then we'll apply the relation to all the lines. So here you can see I created 4 lines. I will make sure that all the lines are along G direction. So I will convert all the lines along G direction first. Here you can see all the lines are along G direction, but they are opposite right now. So I can simply drag them and make them pointing towards upward like this. Like this. Now I want the length of all the 4 lines to be equal. So first I will select all the 4 lines. And the moment you will select all the 4 lines, you will get an option that says equal. Just apply that relation and all 4 of them became equal. Now what is the benefit of having equal lengths? If you adjust any one of them, all 4 are getting adjusted. Now what is the benefit of 3D sketch? So let's say you created a 3D sketch like this, right? And that is only possible through this 3D sketch command. And once you will click on finish a sketch, and let's say you have this 3D sketch, and now you want to convert this as a structural component. Very simple. There is a tool panel, special tool panel for that, and that is known as weldments. And that I have not explained you in the beginning, because uh, learning the feature tool panel and doing the normal solid modeling stuff is more important in the beginning. And once you have the knowledge and the control, then you can start learning different tools, specific tools and panels inside SolidWorks are like sheet metals and weldments, because these are mostly used in the industry. But first you have to learn all the basic of the tool, because you have to master all the basics of the tool. So you can see right now we are into weldments. And now if we'll click on this structural member, then I can select the structural member for this structure I want to use. Let's say I want to use ISO standard, and the member I want to use in case this is pipe, right? And let's say I will also select the sizes. We have only limited sizes over available over here. So we'll select the sizes, and then I will specify all the members for which I want to apply a pipe. That's it. I don't have to do any solid modeling or any stuff. Just select your components. So the orientation of these lines are vertical. So in one group, you can select vertical lines only. Then I will click on new group, and then we'll select the horizontal lines only. And then we'll click on a new group, and we'll select these two as well. And automatically you can see the corners are getting adjusted. The cuts basically are getting adjusted, because this is a weldments. You don't need to worry about the cuts and all those stuff. And the moment you will click on finish, you can see automatically this cuts got adjusted. So you can simply join the points, and you can apply some corner piece or welding or anything you can do at the ends. But still you can adjust more. If you'll go and modify this feature again, then you can see these joint options. We have different kind of joint options. So right now we have applied this kind of joint option. So if we'll change this to this one, the shapes will be a little different, right? And at the bottom we have few more options, but don't worry about that. Simply select that other one and change that. And now you can see the lines are like the end points are already getting cut, like, so it will be completely sitting onto this vertical pipe. So this was very quick modeling that you can do. And even if all the time, if you want to change the like feature, just go and edit. And instead of pipe, let's say you want to use a C channel, right? So C channel is also a structural member. So select the C channel and then select the size, and all of your designs will get updated. So right now for this C channel, I can see there are so many errors we are getting. Maybe the reason could be because the size is the sketch size that we have selected is very small. So maybe we have to adjust the sketch first. So we'll go to our 3D sketch, right? We'll click on edit, and let's adjust the 3D sketch first. We'll make it little bigger, right? Let's make it horizontal first, and let's make it bigger. So I can let's apply a perpendicular constraint between these two one, and let's apply a perpendicular constraint between these two one, right? And okay, so we did something wrong. So let's make this along x-axis, and let's adjust the size now. I will make it bigger in size so I can show you that demo as well. I will also increase the length like this. Now if we'll click on finish, now if we'll go onto the pipe, click on edit feature, you can say for these structures, let's delete all these three groups first, right? And now here inside pipe, I will change this to C channel, and then in the side I will select the smaller one, and now I can define the channels like this. And the moment I will click on finish, you can see, okay, so again we are getting pipe. Anyway, there is some problem, just a second. So basically that way we can apply weldments to our design or drawing, right? I think so there is some bug in the software. That's why the old commands that we all already removed is still visible. Okay, anyway, let me save this drawing and reopen it. But that is the way you can do this stuff. You can do the design, right? It will save you a lots of time whenever you are working with structural members, like any component where you need to make complex shapes. So here you can see that is gone. Maybe that was bug over there. That's why it was happening. So we'll delete this one as well. Now we'll go and click on edit. Okay, Let me delete this one as well, so I can create a fresh one using this sketch. So we'll go on to the weldments, we'll activate this structural member, and then we'll select all the 4 vertical lines first. You can see the channel is getting applied. So this kind of profile is already getting applied. But here, the moment I selected all the 4 vertical lines, you can see the corner is getting used as a reference. So that options we can align, like that we can do using this locate profile. So if we'll activate this option, we can change the location of the profiles. So now you can see for all of them, the center point is getting used, right? So now that is the right thing. I will click on new group, and in the next group, I will select these 2 ones, and we'll click on new group and we'll select these 2 ones. And the moment you can see that these 2 ones are, the orientation is not right. They're getting horizontal, whereas this one is vertical. So maybe we have to change the orientation as well. So let's change the orientation. We can change the angle over here as 90-degree, like this. And then we can click on finish. And the moment I clicked on finish, can you see the C channels are getting placed like this, and we get a structural member like this using this C channel. So using the same 3D sketch, we can all the time change the profiles, but that is also possible through weldments features only. So these are all the things that you can do inside SolidWorks if you are following these kind of tools and stuff. Now let me know if you have any questions. Just let me know if you have any questions. Adis, let me know if you have any questions. Hitesh, just let me know if you have any questions. Okay, no questions. So again, I will upload this recording into our panel. And also one more thing, we created a SolidWorks group that will be active for more extra 1 month. And after that, I will close that group and will add all of you to our main group that we run about CAD design and stuff, where we have already more than around 1,000 members are there. So we'll be adding into that group as well to all of you. And but all the recordings for these courses and the live streams we did will be available for you all the time into the dashboard. Apart from this, also, if you have any doubts, questions, queries, you can drop me a WhatsApp message. You can write that into the main group where I will add you. But this group will be active for at least for a month, and after that we'll be closing this group and we'll be adding you into the main group, main CAD community group that I used to host. So this was all about, I think, our SolidWorks bootcamp 2025. You were onto the batch 2. So in batch 1, we have a huge number of members, like almost 70 members were there, 70 learners were there. But in the batch 2, we got very small number of members, and because of that, it was also possible to interact you with very easily, right? We can ask, we can talk about your queries and questions. It was easy for us just because of that. So if you have any questions, just write into the chat box, or else just write N so we can finish up this session, because time is also limited for us today.